Good evening, everyone. Welcome to our last session on Aspen Hysys. In our previous class, which was held a few days ago, we treated the example, and this was the last example we talked about. I started from, the introduction of Aspen Hysys itself, what it's being used for, and how it's been applied. We talked that equation of states. I also introduced you to the property panel of Aspen Hysys, how to impute components that will be used, how to also specify or pick the proper equation of state. Then after that, I'll introduce you guys to the simulation workspace. We talked about the model palette, which is by my right. You have your feed stream, you have your energy stream, supply 1, supply 2, supply 3, which is our splitter. We also looked at how to split the flow or our output into different fractions. So the amount of output lines we have. So in today's class, we are also going to look at few other examples. We're also going to look at few other examples that has to do, we are going to do few other simulations, then we conclude, the class on Aspen Hysys. Then we are going to be having our closing session tomorrow by 8 p.m. And we are going to drop more information with regards to we are going to drop more information with regards to the advanced class. Okay, so I'm going to create a new case or a new simulation. Whenever you create a new case, this is what you are going to see, a blank space. Just give me a minute, my Hysys is coming up. Okay, so this is what you are going to see. By my left, you have all items. The first thing you have here is your component list, your fluid package, petroleum assay, which is if you are working on crude products, you have your reactions. This has to do with those, or when you start carrying out some chemical reactions in Aspen Hysys, like your CSTR and plug flow. You have to specify your reactant, you have to specify your product, stuff like that. Then we have component map and user properties. But for this, what we are going to be concerned with is basically our component list. You add your component list, add your fluid package. So right now, I'm going to share my screen, and we're going to look at one or two other examples. We are going to look at pump. We are going to take a few examples on pump for this class. So during the course of this class, if you have any question, please do not hesitate. Kindly ask your questions where necessary. For those that are online, I would like you to drop a message on the chat box. I'm online. If you're online, kindly indicate. Okay. Yes. Yeah, if you're online, kindly indicate. Okay, we have 3 views. 3 persons have already joined this meeting. Okay, I believe you all can see my screen. So what we want to do, we want to simulate a pump. We want to simulate a pump, how the pump operates. Okay, and for us to do that, we have an example here which says pump increasing water pressure for 1 atm to 5 atm. Problem statement: a pump is used to increase the pressure of water from 1 atm to 5 atm. The inlet temperature is 25 and the flow is 10 kilogram. That's the mass flow is 10 kilogram per second. Determine the work required by the pump. Now, from this statement, this problem statement we need to put it into Aspen Hysys and determine the um, the work required by the pump. We can also uh, check the output temperature of this. So if we increase the pressure from 1 to 5 atm, does it affect the temperature of the fluid? So we're also going to see that. Okay, so what I'm going to do now is to switch to Aspen Hysys and share my screen. So the component we are using for today's for this simulation is water. So I'll click on add, search, I'll type water, which is H2O. I click on add. A component list has been added. Now, the moment that particular item has been solved, you see a check mark, But when you have an error or a warning, you see a circle with half red. So I'm going to click on fluid package, click on add. What I'm going to use is CRK. Then switch over to my simulation. I'm going to click on my stream from here, my material stream. Double click on it. Stream name, click once and type water. Then the temperature is 25, the pressure 1 atm. Now my Aspen Hysys is indicating that there's unknown composition. I haven't specified the composition. I'll click on composition here. Click on this, click on edit. I'll type 1, click on OK. Oh, unknown flow rate. I haven't specified my flow rate also. My mass flow is 10 kilogram per hour. I can't remember that. 10 kilogram per second rather. Now it has been solved. You can see OK at the bottom. Okay, then for pump, I'm going to type pump here. Now I have pump. Click on it. I also added a material stream. I'll double click on it. Type output. Output. Yeah, not specified. I'll double click on my pump. Select the input, which is water. Select the output, which is output. Now, the moment I've done this, it says energy required. For a pump to work, it needs a source of energy, an electrical energy. So I'm going to specify that, which is P100 as my energy. Now it says unknown duty. Remember our problem statement said we are moving this, we are increasing the pressure from 1 atm to 5 atm. I'm going to double click on my pump, come down to parameters. Now, there's a change here, delta P. I'm going to type what 4, no? I'm going to, you can either use delta P, which is change in pressure. So the change in pressure is 4. So if we, our initial is 1, our final is 5. So for us to get our change is in a final minus initial, which is going to give us 4. So yeah, our change in pressure, sorry, our change in pressure is 4. I'm going to delete this. Change in pressure is 4 atm. Okay, now you can see it's pressure ratio 5. It has calculated it. For this, we are not giving our efficiency, but a situation where we are giving the efficiency of the pump. For now, the adiabatic efficiency of this pump is 75. Then we can see the duty here, which is 5.3646 kilowatts. So that's the energy required by this pump to move um, the pressure from 1 to 5 atm. I believe that's clear. Now you can see that this has been solved. All right, come here, right click, show table. Then I can see the show table again. Okay, so with this, there's a slight increase in temperature from our output. The temperature in is 25. Our temperature out here is 25.03. Our pressure here is 1 atm. Our pressure here is 5 atm. So I don't know if anyone has a question. Please, if you have a question, I would like you to drop it on the comment section. I believe there are no questions. We are going to look at some other examples. Still with our pump. Okay. So for this, pumps are used to move liquids. And it's also, the pump increases the pressure of the liquid. We have water at 120 at 120 Celsius and 3 bar. It's fed into a pump that has only 10% efficiency. The flow rate is of water is 100 kilomole per hour, and its output pressure is 84 bar. Using Penn-Robinson equation of state as determine the output temperature. Okay, so still with this pump we have used, I'm going to change the equation of state method to see if it affects um, our output. So for this, we use SRK. This might not be significant in this case because of what we are using water. So I'm going to use NRT. I'm going to use NRT. Then switch back to simulation. On hold, activate. Okay, it's a slight change in our temperature. This is 25.04. When we used SRK, it was 25.03. I'm using SRK again. Said, do you wish to be left in holding mode when entering? Say yes. And it's going to keep this on hold, activate. Now you see that what we have here is 25.03 Celsius. That is when we are using SRK. But when we use NRCL, it gave us something different. Let's use Pen Robinson. Activate. Pen Robinson also give us 25.04. So this is why using the correct equation of state is necessary. Because if you don't use the correct equation of state method or the correct fluid package, it's going to affect the result. This is just water we are using, only water. And we can see variations, little variations. Now compare it with where you have lots of components involved. There's going to definitely be um, a lot of changes. Okay, so for this, the example we looked at says water at 120 degrees centigrade and 3 bar is fed into the pump. So what we are going to do is I'm going to change this feed from 25 to 120 degrees centigrade. Okay. Then pressure here is 1 bar. I'll just leave it at 1 atm. I'm going to leave it at 1 atm. Okay, or I can still change it to 3 bar. To 3 bar. Okay, 3 bar. Okay, we have 3 bar here. This is the input. Now it says the flow rate of water is 100 kilomole per hour. So I'm going to change this. Let me put this on hold. Flow rate of water is 100 kilomole per hour. I'm going to change this from mass flow to molar flow. 100 kilomole per hour. Enter. So okay, I'm going to activate this so that I can calculate. I'll double click on this. The question we are working with, or the problem statement says, an heat output pressure for the pump is 84 bar. The output pressure. So there are two ways of doing this. There are two ways of doing this. I will decide, I will delete this and create a new output stream. I'll name this water out. And what I'm going to do simply is specify the output pressure, which is 84 bar. That's the only thing I'm going to do here now. We have choose the fluid package we want, determine the output temperature. So for this, I'm going to double click on my pump and click on water. And don't know, activate. Okay, a consistency error has occurred. This can arise when two objects calculate. Okay. So going to double click on this, come to parameters and delete all this. So that's where I'm getting my consistency error from. I'm going to delete this. Make sure that every parameter I set before is being removed. So we have 10% efficiency. I'm going to reduce this also to 10%. Hit enter, 10%. Then my product stream, which is water out. Water out. The pressure, the output pressure is 83, if I'm correct. 84. 84 bar. I'll double click on this, specify my output. Now it says unknown duty. Unknown duty. Normally the moment you specify the output temperature, the output pressure rather, Aspen Hysys is supposed to calculate. Okay, yeah, I'll come to worksheet. No, initially is in design. I'll click on worksheet. Water out, I'm going to specify the pressure to be 84 ATM, 84 bar rather. Okay, the moment I specify the output pressure, Aspen Hysys has calculated the duty. That's calculated the change in pressure and the pressure ratio. So the pressure ratio is what, 28. Let's look at the output, the properties of show table. So for this, our temperature here has increased to 138.1. Okay, our output pressure here is 82.90. Why is this? Because the moment you increase pressure, there is always an increase in temperature. The moment the moment you increase temperature, the moment you increase pressure, there's always an increase in temperature. Now, our pump is operating at what? An efficiency of 10%. Let's increase it to 20% and see the output of. So you can see that we have 8128.4 as our temperature now. Initially, when it was 10, we have 128.4. When it was 10, it was 13 what? 138. So what can we deduce? Now you see why when I started, I told you that you could carry out tests from with your with Aspen Hysys. We want to see how we can reduce the amount of energy we are releasing, or yes, wasted energy, wasted heat. Because this increase in temperature, we have 120 and we have 138. If we there's an increase in temperature of about what 18, 18.1. If we want to reduce the amount of heat, what do we do? It means the efficiency of our pump simply needs to increase. And how are we sure that's going to happen? We can do tests here, right here, by increasing the efficiency. The moment I increase it to 30, temperature has dropped to 125. The moment I increase this to 75, the temperature dropped to 121. You understand? Now, if I increase pressure, what is going to happen? So it means you can carry out different tests with Hysys. So we can see that at 75-degree efficiency, we have 121.2 um, degrees centigrade as our temperature. But when we reduce it to 10, we are having a much higher temperature because we are doing more work. The pump is doing more work at this point in time. So I don't know if still waiting for questions from you guys, contribution and all of that. Okay, so this is the next example we are going to treat we are going to treat in this session. Then this is the last example for Aspen Hysys. Where is this? Okay, so this example, we have a flash separator. A flash separator is simply a device or equipment used in several industrial applications vapor, to separate a vapor liquid mixture. It is performed to determine a product's condition and phases. It is also referred to as a flash drum or knockout drum. So this is it. We have the feed, 80, 60 moles benzene, 40 moles water at 1 atm. These are the properties of the feed. We also have our flash drum here, and this is what the property method used here is ROK, Aspen. Then we have stream 1, stream 2, and stream 3. But for this, we are not going to be using a we are not going to be using three stream. We are just going to use two stream. Yeah, okay. So for this, we have the feed. I'll go back to my Aspen Hysys and start the modeling or start the simulation. So from here, I'm going to create a new case. Okay, so we have the same procedure. Select the components. I'm going to type water, add. I'm also going to type benzene. Okay, have benzene here, add. Click on fluid package. We have ROK. So let's look for this. Okay, since we can't find that, we are going to use NRT or Uniquark, whichever one goes for this simulation. Then switch to the simulation window. Our feed, select the feed, double click, type feed, enter. The temperature of this feed is 120. Pressure is 180 kilomole per hour. Hundred kilomole per hour, 120, 1 atm. Composition, we have benzene, which is 0.6, no fraction, then 0.4, total of 1. Our feed is fully specified. Next thing I'm going to use is my two-way flash separator. I'll use this as vapor. I'll use this as, I can use bottom. I can use this as top. So all I need to do is double click on this, specify my top, specify my bottom, specify my feed, and Aspen Hysys does the calculation. Very easy. So it's not difficult. Um, it's a very easy step. So the same thing if it was a three-way separator, you specify the three streams, but we are not going to do that in this class. So if you have any question, please ask with regards to what we just did now. If there is no question, I've come to the conclusion of today's class on Aspen Hysys. Okay, thank you all for participating. No question. We are going to see tomorrow by 8 p.m. for the closing session. If you have any concern and more information with regards to the advanced class will be dropped on the group, and also we are going to talk about that during the closing session as well tomorrow. Thank you all for participating. We are going to see tomorrow. Thank you.